Hello students, here is the video for Thursday night, April 25th. This video is going to be about the topic of inscribed angles. What's the difference between an inscribed angle and a central angle? As you can see down here, we have circle P and we have a central angle APE. Now central angle APE, what we know about central angles is that the measure of their angle is equal to the measure of their arc. So for instance, if this is 80 degrees, then I know that the measure of the angle is 80 degrees. And that's what the facts we know about central angles. So what's an inscribed angle? Well, an inscribed angle is an angle such as the angle EMU. Angle EMU is called an inscribed angle because its vertex is on the circle. So M is on the circle, and then the other 2 points we use to label it are also on the circle. Of course, the angle goes forever. The sides of the angles go forever in these directions. But the inscribed angle we're looking at is a part inside the circle, and it is the angle right here. Now, inscribed angles, if this arc was 80 degrees, then the inscribed angle theorem says that the angle is half the intercepted arc. So since the arc is 80, the angle is 40. Since the angle is 40, the arc is twice as big, 80. And that's the fact you have to remember. So I'm going to pause the video, and when it comes back in just a second or two, we'll have a new picture and some problems to do. So here we are back with a diagram where we want to find a couple of things. Now if you look at this diagram, you will see that we have a couple of angles. So the first angle you can see is right here. We can call it angle X, and decide in your mind if it's an inscribed angle. So yes, it is, because the vertex is on the circle and it intersects the circle in 2 other places. And then also decide if this angle right here is an inscribed angle. And the answer is angle AYB is also inscribed because Y, the vertex, is on the circle and it intersects the circle in 2 places, points A and B. And so the 2 problems that we want to do are find the measure of angle 1 and find the measure of arc AB. And so what I wanted to have you do then is solve this problem in this way. Let's look first at the measure of angle 1. Pause the video and then see if you can do it. And then I want you to find the measure of arc AB based on what angle Y is. I just wrote that in there at 72. So pause and you can figure it out. So we're back, and the measure of angle 1 is since it's an inscribed angle, is going to be half the measure of arc DC. Well, arc DC is 86 degrees, so it's 1/2 the measure of arc DC. Therefore, it's 1/2 of 86, which is 43 degrees. And then the measure of arc AB, arcs are twice as big as inscribed angles, so you can say that it is 2 times the measure of angle Y, and the measure of angle Y is 72, so it's 2 times 72, or 144 degrees. So if you got both of those, you understand the basics, and so I'll do another picture with some more complicated problems. So here's the next problem. Make sure you pause and copy it if you need to so you have everything. But as you can see, we have a circle. We have a number of inscribed angles. But what you can see is that the angle at H is inscribed in arc IJ, and the angle in K is inscribed at arc IJ as well. And that's an important fact to notice, that they're both inscribed in the same arc. So what I want you to do first is find the measure of angle H, and then after you find the measure of angle H, please find the measure of arc IJ. So pause the video and then you can do that. So now that you're back, we're going to go ahead and do this, and what I notice is that both of these angles are inscribed in the same arc. What that means is both angles are half as big as that arc. So that means they're exactly the same sized angle. So in order to find angle H, I have to first find X, but that means since those angles are exactly the same size, I can just set these equal to each other and then begin to solve. If I subtract 2x from both sides, I end up with negative x equals negative 54, and therefore x equals 54 degrees. And then finally, what's the measure of arc IJ? Well, since angle H is 54 degrees and it's an inscribed angle, it's half as big as the measure of arc IJ. So I can now say 54 degrees is equal to 1/2 of the measure of arc IJ. And once I say that, I can multiply both sides by 2 to get rid of the fraction. So I get 108 degrees is equal to 2 times 1/2 is 1, the measure of arc IJ. And now I've solved for both missing pieces. So here's another example problem for you to copy, and our goal is to find measure of angle U. So pause for a minute, try and work it out, and see if you can find measure of angle U. So we're back. Hopefully you did that fairly quickly, but the secret is to notice that SU is a diameter. And since it's a diameter, that means that arc STU is a semicircle. And since it's a semicircle, that means its measure is 180 degrees total. So when you look at angle S, it's inscribed in arc TU, and angle U is inscribed in arc ST. Therefore, those two arcs add up to the semicircle. So those two angles added together are half of a semicircle, which means half a semicircle is 1/2 of 180 degrees. So that means those two angles together add up to 90 degrees. And so therefore, I would go ahead and add each of these angles, which are 3x plus 1 plus 7x minus 1, and that should equal 90 degrees. And that gives me 10x plus 0 equals 90. So divide by 10, so x will equal 9. And what do we want to solve for? The measure of angle U, and U is 7x minus 1, so the measure of angle U is equal to 7 times 9 minus 1, which is 63 minus 1, or 62 degrees. Okay, so that ends our video on inscribed angles. So good luck and enjoy yourself with this. The assignment is 10.4, and we'll be doing that in class tomorrow. I think you'll find you do it very quickly.